Well, I've restarted the program and restarted the new feed, but whether or not it keeps that URL, that'll be fascinating. So, let's have a look. We are now started. We're on.
All right. Hello. Sorry about the intermission. Our audio completely crashed. So?
My stream status is just saying okay. Usually it says good, and with that I've got a message. The primary stream, we are not receiving video data at a fast enough rate. Your viewers may experience buffering. Ensure your connection is fast enough or consider using a lower bitrate.
Do you want to put it to non-action sports mode?
Non-action sports mode?
Yeah.
I wonder if I can change it. Hang on, out the settings. Quality may be reduced. Yep, I'll do non-action. I'll do YouTube 720p recommended. 2.6 megabits. Done.
That's better. That's half the, isn't it? That's half the bit rate, yeah?
Yeah, that's half the bit rate. Yeah.
Yeah.
And it's still just saying okay. Yeah. Or maybe it needs time to come good, perhaps. I don't know. Yeah, it's reset the viewers, so it's booted all the viewers out.
Oh, great. That's...
Well, is your feed working?
No.
No.
I'm going to leave it for a bit, though.
Yeah, no, it's a new... I think it's a new URL, so...
Are you able to log into the chat? I don't have the... to tell people.
Ah, right. What, the old chat?
Yeah.
No, I don't have it.
Darn.
They'll figure it out.
Yeah, maybe put a Twitter thing or something. As long as one of them posts a message, which they will.
Right.
So Twitter will be... I don't know. So you reckon I should get Twitter, eh?
Twitter's the bomb, man.
Yeah. What's its like?
Like Twitter, Twitter's good for two things. If you want people to follow you,
Right.
and just things that you do, then it's the place to be. Or if you want to follow somebody you specifically like,
Right.
then it's the duck way to do it. Facebook is just shit for that. It's just
Right.
it's hopeless. I don't like it. Yeah, no, Twitter, you can filter out everything else, but if you only care about 10 people on the planet and what they have to say, you can filter out everything else and just follow them, and and you get bombarded with nothing else. So yeah, it's really good. So yeah, if you have a fan base or you want a fan base, Twitter is Twitter's awesome. It's just a simpler, cleaner way to do it than Facebook. Facebook is just tries to be all end all, and it just fails. It's a jack of all trades, master of none. Somebody says they're still watching with the old URL and it's fine.
You're still watching with the old URL? I'll refresh my page, see what it does.
Yeah, people do, yeah. Gold Ace.
Yep, you're right. Yep, just had to refresh my page.
Just have to refresh.
Just a refresh. I hope everyone's now rewatching. Fantastic. Can someone post in the comments to refresh the page? That would help people out. I know about Twitter. I wanted to know David's opinion on Twitter. I don't have Twitter, but you can't not know about Twitter. It's like
No, I just like it for its simplicity and cleanness,
Yeah.
Yeah.
Yeah, fair enough.
Whereas Facebook, you just get freaking everything. All your freaking relatives all bombarded in with your favourite person you're trying to follow. You know,
Right.
like it's just garbage.
Who isn't your relative?
Yeah, exactly. Yeah.
Wow.
So I had better go. You know, because I have like family and stuff.
So I have friends and things. Dave2, you're under attack. Where? Ah!
Oh dear. Alright, what I'm going to do...
Oh, I have something cool to show people. So the instructions have this thing where you like try to figure, like they're figuring out which motor is which, and you can do it a bit easier. So if I'm spinning this motor and I short all the leads, see how that gets really rough? That means it's this one. This is the z-axis because smooth, and when I short them, it seizes up. Yeah. Easy way. Do we have a bit of masking tape?
Masking tape?
Yeah, or a little
Yeah,
bit.
in our tape box. Yeah, there should be masking
Oh, yeah.
tape in the tape box.
I think that's
Get it
all.
yourself.
I don't think there's masking tape. No. No masking tape.
Really?
There's white electrical tape,
Uh,
which I can probably use for. That'd be fine. We got a permanent marker. Where's that Sharpie we had?
don't know. In the missing stationery box. Did we ever find the stationery box?
Nope.
No.
Nope.
No. Where the hell could it be?
I don't understand.
I don't get it.
I don't understand. It's like, how can a whole stationery box disappear?
I mean, stationery.
There's a
disappears.
conspiracy here.
Yeah, right.
I know it.
Yeah.
If we can't write things, right? There's no.
Right.
I don't know. I'm going on a tangent. I don't know where it ends. Okay. Where the heck is our stationery box? All right, it's got to be here. It's just has to be here, right? Maybe it's wandered under this desk somehow. Alright, well, the Sharpie is over here, so. Okay. So this is the z-axis. And the x and y axes are usually pretty interchangeable. Let's see how they define them here. They're especially interchangeable because the x and y axes have the same travel distance.
I have 10 calculators in here. I can't find one of them.
Stepper motors don't have to move slowly. You can get them reasonably quick. But yeah, they're very precise. The good thing of stepper motors over servo motors is they don't oscillate about their encoder increments. So servo motors will always, in stationary, oscillate between their increments because they physically don't know they're moving until they hit the next encoder position, right? So they constantly go, except usually that's that's like in the arc seconds region, but it still oscillates, like slightly. Steppers don't do that. Yeah, explain a stepper motor. Well, there are a few different types of stepper motors. There's stepper motor, usually they're notated by the number of leads they have, 3, 4, 5, 6. You can have three-phase stepper motors or bipolar stepper motors, and you can have probably more phases than that. They're the only ones I've been using. So bipolar stepper motors is what we've got here. They're the ones with the 4 leads. So that's essentially 2 phases which are out of phase by, 90 degrees, I think. And then, how is it? The sinusoidal, so there's, yeah, okay, so there's 2 different types of stepping you can do, or 3. Actually there's like theoretically infinite types because you can just keep dividing the micro stepping. So you can do full step mode, which is essentially moving between each of the internal notches. So there's these internal notches inside the stepper motors, and the coils interact with those. So full step mode would be going from one notch to the next notch, and often those motors have a label. So these are 200 steps per rotation. So full step mode would have 200 steps per rotation, basically. If I'm wrong, please correct me as soon as I make the mistake, otherwise it will be more embarrassing. Anyway, so there is half step mode, where that essentially you can have each of the phases basically halfway between the steps, and that's half step mode, so you end up having double the number of steps. So you get to 400 steps per revolution. So full step mode is the coil 1 like this, coil 2 is the other way. So you basically, full step mode, you just get these pulses with each phase. And then half step mode, you get things like this. So you've divided it one more stage. And then you can continue to divide it to add more and more micro stepping, and that more and more divisions, and that's called micro stepping. So you can pretty much just keep going, provided that your motors are internally constructed very precisely. So if each of the notches are out of alignment, you actually can't get past a certain number of divisions, because the notch misalignment means that it's not actually, it doesn't stabilize at that point. So with really good stepper motors, theoretically you can divide it just onwards and onwards, but obviously you can't actually do that. You went through a disco yeah, step motors in the disco phases. That's yeah. Yeah.
I set somebody as a moderator.
Oh yeah, I don't know, Faye V seems pretty good. Faye V, maybe Google, search through Faye V's comments, they seem pretty nice.
And I can't block banana pie, I don't know why.
Faye V, would you like to be a moderator? Yep. We can't take volunteers. We'll get everyone volunteering. There's this Faye V person. Now they're yaying.
Oh yes, okay. Faye V is now. Hang on.
Yep.
Faye V is now a moderator.
You're now a moderator, Faye V. So if anyone's being completely nuts, you can get rid of them. But if they're kind of being constructive, even loosely, then they're probably okay.
Cannot get rid of banana pie.
Alright, so yeah, so stepper motors, pretty much the ideal stepper motor, micro stepper driving, is actually true sinusoids. So if you could drive two 90-degree out of phase sinusoids, you'd get a perfect stepper motor driver. That's like true sinusoidal drive. Faye V for president. Whoever that is. They seem non-aggressive. It's great. Anyway, so yeah, so this would be this point, and this point would be a full step. So you can actually draw rectangles for each of these phases, and just put the phases 90 degrees out of phase, and then you get a full step, and you can just keep dividing along those sinusoids. That's how a stepper motor works. Yep. And there are lots of different step motor drive techniques. Probably the most common's, well, no, the most common is just probably full step. I don't know. Maybe microstepping is becoming more common.
I cannot get rid of banana pie.
Why?
I have no idea. It just doesn't work anymore.
Favies are becoming quite famous. They're now getting votes for president.
Okay.
Yeah. It's not letting you post links. Yeah, sorry about that. Can't do anything about that. Did I learn this stuff in uni? No. I wish. I probably shouldn't say too much. Okay, so where are we up to now? Oh yeah, I was labeling axes. So this is the z-axis here. I can't actually do that cool trick with these ones because when you have two different motors that are hooked up in series, they will, if you short two step motors, they will spin each other. But if there's drag on the second motor, then they actually like kind of resist each other, kind of like when you short the lead. So I can't really find out which one is this. Let's have a look. Maybe I can. Okay, let's short those. It's not that. Alright, that's good. Okay, that's very difficult to move. Okay, so this wire corresponds to this step motor here, because when you try to spin the motor, it makes it very, very difficult. So that means this is the x-axis. So here we go. Just put this in here. Okay. So, I wish I knew what I just said this was. I think I said it was an x-axis, but I have a bad short-term memory, so we'll find out. So, this is the y-axis. Great. I'm just going to strip these. How many hours have gone into this build so far?
7.5 maybe?
Yeah. Maybe a bit more. 8 maybe. I don't know. I'm sure someone will calculate it in the comments in a few moments.
Okay, I'm starting some logging, but it's not going to be the real thing. It's not going to be the real deal.
That is one beautiful rock. Yes. Yes, it is.
Rock?
I don't know. Someone's comparing the Inventables machine to a rock.
Okay. Never float your boat.
I'm sure there are many similarities. It has colour. It exists. There you go. Many similarities.
Alright, I'm going to leave that running overnight.
Alright. Our moderator might have vanished.
Right.
Oh, good. No, they're still there.
No, still it.
Good. And they're not going nuts, so that's great.
Alright, well, I'm off. Here you go. Just hit the stream button on the Wirecast software. It's got a little red dot on it.
Alright.
Just hit that and it'll stop.
Okay, will your computer log off or anything?
No, but I can remote log in later and shut it down.
So worst case scenario, then you can turn it off.
Oh, then I can turn it off worst case.
Alright, cool.
So, yep.
Good. So we're all good. Alright.
See you guys. Thanks for joining us. I got to go. You know, I've got a family and all that. 7 p.m. here. So, yep. That's the cut-off.
Yep.
I'm lucky to get 7. So, I'll leave you in David2's capable hands. Are we still
Oh man, what was that show where there was a bunch of creatures and if they thought about them not existing, they stopped existing?
Ah, right. No.
Oh, what the hell was that?
No idea. Don't know it.
It was some. I was like Unforgotten Realms or something, I think it was called.
Right.
Anyway, there was this thing where if you thought about not existing, the guys would stop existing, and then obviously they couldn't do anything else, and the whole species went extinct.
Right.
It's like, don't think of elephants. Anyway, one of the commenters just said they blocked themselves. It's like, but now if they think about blocking themselves, they might be like, can I block myself?
Oh dear.
Yep.
Alright. Wallet, mobile.
Everyone says bye.
Bye.
No, you're still here. Thank you, by the way, for moderating for us.
See ya.
See ya. Have a good one.
You coming in tomorrow?
Home. Same thing as
okay.
Fridays, yeah.
See ya.
Alright. Alright guys, Dave has gone. Okay. How long will I stay around for? I'm going to finish this damn thing. This will be finished. What? 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 Okay, that's a dumb diagram. So in the diagram we have a row of 10 headers on the x-axis, this one here. Oh no, sorry, that was just wrong. What are they doing? What? Oh, they're talking about these headers. Never mind, I've gone mad. Yep. Okay, this is quite simple then. Alright, well, this isn't a lot of room they give me to hook these up, so let's just see that. So when you move these axes, I expect these cables to change length very slightly, so it changes by about a centimetre. I'm not sure if you can see it on the video. So I can't go beyond there. And this one, that one's fine. Okay. He's getting sloppy. Yeah. I was getting sloppy from like 6 onwards when I put the board upside down. Yeah. Oh well. Let's do this. So these use the DRV 8818, whereas my board uses the DRV 8825. So let's compare their layout a little bit. So they've got a bigger current sense resistor, but that's because they are current limiting. Yeah, they've spared no expense with large wattage current sense resistors. Very nice. Although I like to say my headers are nicer and mine are optically isolated. Nice. I'm not actually sure if these are. I think these are capacitively isolated. So I've got some capacitive isolators here. They're digital. They switch, and then so it's essentially modulate, demodulate. No, I'm not 20. I'm 22. The movement sounds like grinding gears because we haven't tightened the belts yet. So the belts are quite literally just, slipping quite a lot. And I guess that would sound like grinding gears. Is the thing worth the cost? I built a CNC for less, if that means anything. Can we order you pizza? Although I might do that myself. Good idea. What? What have I done? Where did I put that thing? I've done something. Ah. Here it is. So, it wanted me to solder these on. It wants me to solder on some headers. These headers. It wants me to solder these on. 2 rows of headers. Let's do that. Pizza teardown. Aren't you tired yet? Yep. Yeah, I'm a bit tired. That's okay though. I want to work on the micro supply, so I volunteered to stay back. So I can. Oh, they've turned the soldering iron off. Okay. Okay, so let's do some soldering. I need somewhere to solder on. This sample piece will be okay. Whatever. There we go. No, I just need to elevate this. In the diagram, they literally use tape. So they put the header on top of tape like that. So that's weird. This is electrical tape, so it'll definitely melt. They've got masking tape, so it won't. Let's use pliers. They won't melt. You want a close-up to observe my soldering skills. I hope you can watch for a distance, because we have fixed focus. I can't, while the stream's on, I can't do anything about it. It's a super awkward positioning. I probably shouldn't have soldered on top of the machine. Committed now. Also, there's mess everywhere and I can't move it. It's hard soldering to try to keep the camera in the view. And I don't even think it's in focus enough for you to see. So, what CNC did you build? I designed my own. I designed my own CNC. So, it's a me CNC. I don't know. No, I built it. I built another CNC for those who didn't hear before, which took much less time. It took me like 4 hours to put together. I think, even though this looks very kit-like, my one seems like it was much quicker to put together. Mine took a lot longer to actually make though, because obviously I had to cut all the things to length. I wasn't using aluminum extrusion, I was using RHS galvanized steel. So I built one with gal steel. And then welded it. Welding is very quick. So anyone who knows how to weld, it's so much quicker than putting screws in. You just like, it's done. Like, it's just so quick. And if you have mechanisms to adjust for like errors, then it doesn't actually matter if you're like off a little bit. And you can map for certain errors. So as long as you have a rigid machine, then it doesn't actually matter if you get like thermal warpage all that much, as long as the actual rails themselves don't have the warpage. Okay, so we've soldered these on. Those of you who want to see my hacky soldering, here you go. It's fine, I think. I don't know. I didn't go to Newcastle. I go to UTS, University of Technology. Okay. All right, so, There's some thermal vias here, assuming that this thing gets pretty warm. although it doesn't come with a heatsink, or maybe it does. Doesn't look like it comes with a heatsink, so yeah. Okay, what am I doing? That. Okay. Step 14 of the instructions. Anyone wants to follow along? Wants me to unscrew these things, and I'll do that. Where's the thing? There it is. Okay. Get in. There we go. Okay, so we're just going to unscrew all these. CNC Miller heatsink. Yeah, that's actually a good idea. Although they would have put a heatsink on this if it was problematic. Like, it's not going above, I don't know what the type of solder is, but let's say it's probably not going above 320, and that's still pretty hot. That's pretty hot. The boards aren't on fire, so they're fine. No. Yeah, there is a fan. There is a fan. So it's passively cool. It's not passively cooled. It's actively cooled with a fan that's somewhere. There was a picture of a fan in the instructions. Yeah, there's a fan. Yeah, but there's no heatsink. All right. Oh, why? Blah, blah. So I've done black, green, blue, red. Black, green, blue, red. Fantastic. It's the correct order. And they want me to solder in black, green, blue, red. Red, blue, green, black. What? Red. Red, white, green, black? Oh. Okay. Let's do this header thing. They've picked terminal blocks which are they've just got enough room to fit these wires into the undo it even more. Is Radio Shack still around? We don't have Radio Shack in Australia. Well, we might somewhere, but we don't have those commonly. I hate these type of headers. Terminal blocks. Ugh. I'm going to put one in at a time, even though it means I have to bend the heck out of the wire. Black, green, white, red. Okay. Oh, one of the strands. Oh, these. I should tent this. Didn't measure mine. Yeah, J-car's the thing we see around Sydney. There's our other options were like Dick Smith, but now it's become more of a consumer electronics type place. And then we also had like the Powerhouse, Dick Smith Powerhouse, and then I haven't been there for a while. I don't really know what they have. Now it's all online, really. Ha! Great success. Or was it? Yes. Doesn't matter anyway. There's a cool thing about stepper motors that if you hook them up the wrong way, you can swap some wires and then they go the other direction. It's great. Yep. Yeah, because what it actually ends up doing is you end up moving this. If you swap any two wires, actually that's wrong. Don't swap any two wires. If you swap two phase wires, then you end up swapping this to be over here, and it ends up being 180 degrees out of phase from where it was. And for those who are into math, 180 degrees is effectively 180 degrees phase shift is effectively timesing it by -1. So you end up going the other direction. Yeah. Woo! Math. Dick Smith is pretty overpriced. For those who have noticed how frustrated terminal blocks seem to make me, you'll notice that my board, my CNC controller, has no terminal blocks, which is fantastic because I hate them. I hate them. They're just so much work, and especially with stranded wire. Every time you try to put one of the wires in, you end up. It happened again. One of the strays comes loose, and then you risk shorting or something. It's horrible. Okay, here we go. Got one in. Haha. No, it fell out. That's annoying. This is perhaps the most awkward part of this build, apart from when the thread. Oh my gosh! Oh my gosh! Oh my gosh! Oh my gosh, terminal blocks are the worst. They just fall out. They don't hold wires properly. I should be tinting these, but I have been told not to. For some reason. I don't know why. Is there a reason you don't tint these wires? Let's read some comments. Yeah, the wires are too thick. It's only, it only just fits. Yeah, and then you can't tighten onto these very well either. So even when it does, it slips out, and it's so that's as tight as I can probably get it without a larger diameter screwdriver, because I can't get the torque without slipping. Yeah. Okay. Come on, terminal blocks. Stop being terminal blocks. Why couldn't I just solder on a header? Or like a... That would be great. That would take me like a third of the time. It'd be way cooler. I could plug it and unplug it without being traumatized by the thought that I'd have to attach the damn thing. No. Oh. So to assemble. It looses. Oh, does tuning the terminal block things lose tension? That's interesting. Thank you. I did not know. Dave1 has gone home for dinner. I think someone said that. So it's just me. Me doing up terminal blocks, which I hate. Damn terminal blocks. Four Dave not found. Yeah. Yep. We've been pinging him for hours. Arrgh. No, Dave lives within a reasonable distance. I probably shouldn't give numbers, but he lives within a, something that you'd be alright with driving to work. Yeah. Alright, so that is something. There we go, no more. Ah, the thing slipped out. Stupid Z-axis terminal block. I am going to glue these. I could like desolder these terminal blocks, just solder the wire in. If I get too frustrated and this just keeps happening, that's going to be a thing. We have a pretty good desolderer. There we go. Dave, how you going? Yes, now we've got some moderators. Awesome. Alright. Mike Whitson, that's fantastic. Alright, so now we're up to the Arduino. So the Arduino mounts in this, in here. So I guess we have to be pretty careful which way we put this. But it's actually pretty neat how it mounts after you do that. So it's going to mount like this. Yes, right on top of the Arduino. That's what these right angle headers are for. No, sorry, that's what these straight headers are for. I don't know what the right angle headers are for. Let's open the Arduino. Make sure the USB port's in vaguely the right direction. We probably don't have the M3 screws because that would just be too easy. powered from USB. Okay, so this appears to be the right way. Alright, so these things appear to be the right way, although the picture has a different Arduino. Of course it does. So it's got I've got the SMD edition of the Uno, and it has the through-hole one, which is not a big deal, I guess. Okay, M3 screws. Where are you, M3 screws? Okay. There we go. So I'm assuming these are the right screws. Doesn't provide a washer or anything to protect the surface of the PCB, so the solder mask is going to get a bit scratched. That's okay. Okay, so just put the first screw in now. If I can just get it straight. Oh man, I'm terrible. Come on. Come on. There we go. Oh no, we found the M3s. Sorry, did I not say that? Yeah, I found the M3s. They were no problem. Actually, I found them pretty much as I was saying they're missing or something. I was saying something. Get out. Put the USB port through the square hole on the G-Shield enclosure. Righto. I did it again. Magnetic Allen keys would be good right now. Okay, here we go, finally. Mrs. EEV Vlog says hi. Hello. Dave, don't worry, there's no large fires in the lab. So this should just plug straight onto the top of this, but I don't have enough table space. I'm going to have to turn the soldering iron off. Got to make some more space. Sorry if the audio gets a bit worse. I'm just moving the laptop slightly closer to it. Okay. Oh, where did this wire come from? Okay. This damn terminal block came undone again. Ah! Freaking Z terminal block. How am I meant to line this up? This is just the picture says just like put it in. It's not that easy. Lining it up is really annoying. Alright. Let's put this in. Okay, I'm going to loosen the Allen keys slightly. and move the board. That's the wrong Allen key. Alright, this one. I'm going to move the board slightly this way so that these headers line up a bit easier. Okay, I've only got a tiny bit of play. Okay, well, that'll have to do. Alright, just put this in here. Come on. Okay, that's plugged in now, but guess what? The Z-axis lead came out again, of course, in the process of inserting the G shield into the Arduino. Just turn that. Okay, so it kind of wants me to put the fan in. I don't really know where. I'm sure the instructions will be clear, or not. Those are the two options. So it wants me to put the fan somewhere. What? Oh, okay, there's a fan cover. Okay. So, where's that? I saw it. We have this part. It's temporary setback. So this is the fan guard. Aha, that's what those M3 screws are for. Okay, so we're getting somewhere now. You know what that's for. Okay, so that's a bit hacky, isn't it? Alright, whoop. Okay. So it wants me to... This looks like a bit of a design afterthought, maybe. So... basically it wants me to twist two different leads together of the fan and this lead here, a portion of this lead anyway. Zip wire. Is this the zip wire? Yes. Okay, so not entirely sure what one of these leads does, but oh well. So I'm gonna. This is like approximately how long does it need to be from there to? No, what am I doing? From there to there. So let's say add a little bit extra. Okay. Okay, so we've got, just got to strip this wire. Whoops. There we go. So to the next terminal block, which is surely going to give me as much trouble as the first terminal blocks, because terminal blocks are terminal blocks and they just irritating. Although this one seems to have gripped the wire far better than the first one. Yeah, this one's far better than those other ones. Okay, I think it wants me to put, it almost looks like this has a limit switch, emergency stop button, because it's got these signal plus and signal minus line, or, oh, that's the spindle. Never mind. Spindle plus, spindle minus. Whoops! Alright, so we're just going to put the spindle wires in now. It seems like the spindle doesn't have speed control, although I guess it's possible. There is a logical signal on the power supply, which I guess could be some kind of solid-state relay control to PWM the spindle, but it doesn't look like this has any speed control at all. Yeah, so the reason you'd want speed control and not just to go flat out is because there are optimal speeds. Depending on the type of cutter you're using and the material you're cutting, you kind of don't want the material to gunk up between the teeth. So often with more rubbery or plasticky materials, you want to use the slot drill, and they have two flutes is what it's called. And the lower number of flutes means that it clogs up less, it reduces the friction, and you end up with the whole spindle running cooler. Yeah. What? What am I doing? Okay. Oh, I was right. But their picture's the other way. What? Oh well. I will fix this. I'm sure there's a reason they have this on the other way. Yeah, I'll just flip it around. Two screws are going to fall out in a moment. Let's undo these. Whoop, what's that? Where's my M3 Allen key? It's here somewhere. M3. Something under this? Oh, just bits of things. Okay, this appears to be not the right one. Fantastic. It's good when... Is this it? Is this it? This is it! Ha ha! Alright, that was not so bad, I guess. Okay, so... take that on off. Oh. There we go. We'll just flip these around. I don't know if the previous picture had it the way it's shown in the current picture. Either way, I better do it to the most up-to-date state. Okay, and then I gotta move this screw and this bolt, these thingos, and put it put it like this, so it goes like that. Okay, so if I just put this in here, yeah, so it screws on like this. This is the way the most up-to-date instruction pictures it. Alright, so just got that back to where it was. I'm sure there was a reason for that. I don't know, probably a reason. Didn't take very long. Certainly worth it. Okay, so just put these screws in here. So these screws, if anyone's doing these the same, if anyone's doing the same build, these screws are not as stated M5s, they're actually M4s. So don't look forever for an M5 that doesn't exist, because they're M4s. This thread is definitely an M4 thread. Yeah. Come on, mesh. There we go. There. Okay. Now it wants me to. Is it V minus? Yup. Okay. It wants me to connect ground here and power here, as well as the fan in parallel. So which way does it put the fan? Oh, doesn't matter. Okay. So let's twist this lead. We don't really want this lead flapping around everywhere, so we'll. Okay, so let's put these ones in first. It kind of wants me to twist these in, but this terminal is one of these, like, it's not as good as the one I was doing before, and it's going to be like really tight fitting. I'll put the big one in first. Stranded wire. So I'm going to tighten these quite loosely and, to leave enough space to put these fan wires in. I should just twist them together. This isn't going to work. Okay. No, stranded wire. Stop behaving like stranded wire. Alright. Okay, this does not want to twist. I don't want to extend the length of these. This might be a soldering job, but let's see what is this supply? What is this supply rated at? I have covered up the label. No idea. Okay, so this fan goes on like this, I guess. And there was a fan guard to protect our fingers, of course. Okay, so just, no, that's backwards. That's right. So this comes with some washers, sufficient number. And it seems like this plate is tapped, so that's kind of nice. These have these, it's like a nut cert. So this has, yeah, nut certs. Which is really nice. I wish the rest of the machine had nut certs. They're fantastic. Make things so much neater. It's a very elegant way to get thread into sheet metal parts. I'm surprised that these bolts aren't too long. No, they're fine. I'm surprised. Okay, so we'll just put some washers on. Alright, so... Oh no, the fan fell out. That's horrible. I'm soldering this. This part is getting soldered. I'm sorry. Wire. So the real problem with soldering here is that you need to add quite a lot of length to the wire, because once I solder it, there's a decent chance that it won't fit in the terminal block anymore, because I will have locked it into a very fixed shape, and you pretty much squish them into the terminal blocks. Well, you're probably not meant to, but these terminal blocks are not sufficiently sized to do anything else. So I squish them in. I have to put some heat shrink on this to make sure it doesn't short or anything. I'll just use electrical tape. Helping hands would be good at this moment, but that's okay. Helping hands the tool, not the person. Okay. So I'm soldering not actually in the terminal block area. So I'm soldering the fan wire to the supply wire, but I'm leaving the terminal block region stranded so it fits in. And I'll just electrical tape it. Okay, just take those together. No, I won't. Change my mind. Okay. Okay, so now we should be good to connect these to the terminal block. And it looks pretty good. That looks much better. Far less hacky than it was. Yeah, it looks pretty good. Alright. I suspect it's time to put the fan on, but I'm going to look at the instructions, because I could have gone completely nuts. Put some Darude Sandstorm on. No, we'd probably get flagged. Alright. I have M3 screws. Haha. If I miss something, I can always undo it. It's only 2 screws. I'm not even doing them up very tight. There we go. Okay, install the 24-volt fan. Crimping? Why am I doing that? What is this for? What? Oh, alright. So there's a header here, a 2.54mm female connector socket thing somewhere, which I'm going to need to solder. Here it is. So I suspect this has the limit switches. What headphones are sitting on your chair? How do you see that over there? How do you know they're headphones? That's a long way away. Nice eyesight. Or, I guess eyesight doesn't make a difference in video playback because you're always sitting the same distance apart away, I guess. They're just good at decoding images. I think they're like Cloud headphones. I think that's the brand. They have like, I don't know. They got virtually no recognizable logos and stuff. I kind of liked that. They had nothing on it. It's great. 24-volt fan overkill much? Yep, probably. Although, probably doesn't matter. It's not a big deal. So these are limit switches, I think. So apparently this is, I assume they're talking about this. So I have this hookup wire. It's twisted. They say it's black and yellow. This is clearly black and white. So I don't know. I'm talking about something different. Ah! Spindle controller. Fantastic. Yes, it does have a spindle controller. That makes a lot of sense. Otherwise, you flat out your spindle all the time and you pretty much burn everything you make, which is horrible. So this wants me to crimp this. Don't have a crimping tool. Well, Dave probably does have a crimping tool. I just don't know where it is. So I'm going to solder these or manually hand crimp them. Okay, so we'll take this off, even though it kind of implied to put it on. And then we'll just plug these in. Oh, they're not really, didn't say anything. Okay, that's unhelpful. Okay. What wires are these? That looks about a foot long. Yeah, alright. Sweet. Someone seeing another colour of cables around the table? Okay, so we're just going to, I'm not going to solder these, I'll hand crimp them. Where's my long nose pliers? Maybe we have a crimping tool that I can see. Not one of the right size. That looks like. Oh well. Let's just put this together. Whoops. So this is a bit fiddly to do by hand. Probably should use a crimping tool, but Dave surely has one, but I don't exactly know where it is, so I will use this. It will be the same. There we go. That wires. Alright, so that's crimped pretty well with some long nose pliers. The way you can do this with long nose pliers, by the way, is you put the insulative area on the first section, crush them a little bit, crush the two outer tabs a little bit, and then once you've done that, if you crush them from the top, they'll crush inwards, and then you end up with a pretty good crimp, and it ends up being pretty much identical to what it would have been with a crimp gun. These wires are tinned. I don't know if that happened earlier. Probably. So I don't know why, but yeah, it's pretty much what I do. Yeah. And then the wire section, that's a bit more fiddly because this wire is tinned, so it doesn't squish like it probably should. Okay, so we've got two crimped wires, not so bad. I don't think noise is going to be a problem with this machine. So the machine's frame's not well, it's pretty rigid, but like it's not rigid enough to avoid being screamingly loud. It's going to be loud. It's going to be very loud. Yeah, like even because of this spindle length, you'll get noise and a fair bit of it. One of these crimps is slightly loose because I can't crush the tinned cable. I'll have to solder it a bit. Oh well. As long as I don't hit the tabs that it locks in with, it's fine. Easier said than done. Yeah, I might as well do the other one. Okay, so that was probably completely unnecessary. Is it possible to make plastic/glass PCB homemade style? You could probably bond. Yeah, you can do that. You need to get the copper clad, like the copper foil separately though. You can etch copper foil without the backing and then bond it. Or you could actually bond it first. I would assume that a lot of plastics aren't. I would assume that the etching compound isn't a solvent to most plastics, so you could probably bond the copper foil onto it after you put toner transfer or UV treat it, and then the his home. It's because his computer's not being used, I would assume. Previously he was using the same computer, so yeah, he wasn't doing anything bad, he was just using the computer, which is... Where's the springy bit? Oh, there it is. What? Is this backwards? No. How do these ones work? So it wants me to put it into the second terminal and the, what is that? Fourth last. So the fourth last, that's this one. That is upside down, probably. Nope. Does not want to click. Usually these click. Probably because I had to solder it because of the previous tinning. That's fine. That's inserted. We'll just put this one in now. Seems like these may actually, these crimp terminals seem a bit strange. They don't have the normal, usually there's like a latching thing on the back. These don't have that. Well, that's not true. They have it, but it's not up, which it probably should be, and it's not on the other side. Although, let's have a look at what happens if I do that. Probably doesn't want to latch. That's annoying. Yeah. Oh well. Just leave like. Push it in. Push that tab down. Oh, that's fine. Okay, so those are now inserted. It's possible I put these upside down there, so let's just double check. Oh, it doesn't matter, it's a flippable header. The stream didn't freeze. Dave is focusing. Yes, that's true. I don't like these crimp terminals very much. Ah! Doesn't want to click. It's not that it won't actually go in the distance it needs to. It's fine. It will go in. Just don't want to clip onto the. How far away is it from it? Maybe it goes there. Maybe it actually does. Oh, that's such a weird thing. There you go, guys. Okay, so we'll just continue on now. Okay, so that is where it's meant to go. And then the next section, I need to plug this in to this. So this terminal block, another one of these damn things. This is one of these terminal blocks. Just strip these wires. Okay, so that's fine, and now we're just gonna Tighten that. Tighten that, and surely these will come out again because terminal blocks are the bane of my life. Yep, that's how bad they are. Okay, so we'll just put that in there. So that's all connected. Now I need to connect in limit switches. Oh man, that's so hacky. Oh, that diagram. Oh no. No, no. Oh. People who can't see the limit switch and why I'm moaning, basically, it wants me to solder all of the black leads together, which I don't like very much. I think it's kind of hacky. Yep, that's what it wants, so that's what I shall do. Let's just shorten this one. We'll twist these together. It actually says to do this. Can't believe it. How long to make it work? Well, if I'm wiring up the limit switches, and I've already wired up all axes, I don't know how weird the software is on the computer. I assume it's okay. It can't be that long now, maybe an hour or two. I guess that could be considered long. I don't know, I could probably get it moving a bit before that. Yeah, it seems like we've configured fixed focus to be always out of focus. Sorry about that, we can't, I don't think we can change it now. It's kind of just got to stay like this. If Dave1 is watching, he might know better. But I don't think there's anything I can do, sorry. This is so hacky. It tells me to do this. I can't believe it. Look at this star connection. Fantastic. It's a feature. Oh man, I made a mistake. The wire fell out. Damn it. While I was soldering it. Alright, so that's soldered. Whoa! Is Dave1 there? No, Dave1 went home. Yep. Whoa! No, that is super duper hacky. What? I guess they don't. Oh, well, what else would they do? But no. This soldering iron's fine. It's a JBC, it's good. Electrical engineering. No, this isn't a signal, this is a ground. So this is actually a power. You know, like this is connected to the ground. It's not a signal pin. It's not power. That was wrong. But yeah, this is a signal pin. No, not a signal pin. What am I saying? Getting tired. It wants me to connect it in this huge monstrosity. So it wants me to connect it over here in the junction, which already has like 3. It's pretty annoying. I could probably connect it to the other side. jack is. I'm not quite sure what this is. It wants me to wire it in from the left in the order X, Y, Z. Hello. Thank you, Brendan. Yeah, Brendan. I don't understand. Could it really want me to connect another thing and then it won't fit? That's crazy. I guess it is a ground. It would be common with the signals. Okay, so I'll pull that wire back. It does indeed want me to connect it to ground, but that's kind of strange because there's a ground pin there. This pin's signal ground as well, but because it's crimped, I can't actually get it in there. Oh, poor Favy. You've got some imitators. Only one admin. Only one moderator there. Yeah. No, I'm looking at the pictures now. I can't believe that it wants me to connect like 6 wires into one terminal header. I just can't believe it. It couldn't. Does it seriously want that? What? So one picture is a picture of him soldering a bunch of wires together. The next picture is a picture of him screwing a terminal block. Oh my gosh. This is so... No. No, it's not going to fit. Not a chance in hell. Alright, I'll untape this lead here. I'll add it to the other wire. I could test if that ground is common with the signal ground. There's no isolation devices on this board though, so it must be. So there's no optical isolation on this board. It's actually pretty common to see optical isolation on stepper controllers, on account of back EMF, and there's no series, no H-bridge diodes either, kind of like flyback diodes, I guess. And there's none of those. So this device doesn't have a lot of protection. No TVS, no MOV. Dave actually asked off camera, I think, before if this device would be okay if you spun up a stepper motor, and maybe not. Maybe not. the assembly instructions can be found, just search X-Carve instructions inventables.com on inventables.com and you'll come across them quite quickly. I'm up to step 14. At which point I got weirded out by their ground configuration. So we've connected one ground batch. Now we're just connecting the power terminal, and it's going to come undone because terminal blocks hate me. Okay, there we go. There we go. Okay. So now I've got to connect the limit switches, so I've got to figure out which one's which. So, time to do that. I've got to make sure the axes line up, otherwise it'll be really, really weird. Yeah, the way the software usually works for these things is that to home, it moves in one direction on one axis at a time in the direction that it expects a limit switch to be until it hits a limit switch. So if you connect the wrong limit switch, because it's only moving one axis at a time, it'll just keep going, or attempt to keep going until, no, it'll just keep going. And that ends up being a bit of a disaster because it just you get a self-collision kind of thing happening. Crimping, crimping, crimping. Yeah. Okay, so we've crimped one wire. I'm contemplating soldering it. Let's just flatten it. I couldn't do this last bit with the first batch because it was pre-tinned, and that meant it wasn't very squishable. So, like, you know, crimping should look something like that, and before it physically couldn't, unfortunately. But now it does. Haha. Okay. What? This wire's like, strands have gone nuts. Crimp, damn it. Okay, there we go. Good. Hiya. 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 Okay, how many hours have you worked on this so far, Dave? I think about 9. I don't know. Probably. A lot of the time, though, we were talking about other things, like, yeah, it's been quite a distracted build. Yeah, on account, hence all the funny mistakes. Yeah. But we're not doing this just for a time lapse, we're trying to keep an engaged live audience. I am. Okay. Okay, flatten the crimp. Good. If I had a crimping tool, this would be like click, clink, done. What time is it there? It's now 8:30, 8:26 on my computer. Now 27. Alright, so now we've got some crimped terminals. Hopefully they'll stick together. They will, of course. Probably. Ooh, I don't know. Alright, so we've got some terminals, and now we have to figure out which one's which, so I'm going to get a multimeter and do a short test. So I don't know if these are not configured in normally open or normally closed. If I had a memory, I would know, but... so I want a banana lead with an alligator clip on the end. Got like 30 of them over here. Okay, so connecting this to the ground is what I should do if I could find a ground. Aha, I found one. I'm assuming that's common with ground, probably is. We'll find out when I do a bit test. Just gonna. Okay. Yep, we got a common ground, not isolated. That's great. So we can easily find out which one this is from. If we just, it's not that one. Not that one. By elimination, it is none of them. That's great. What? 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 Why are none of you triggering this? Oh, there's another one over here, is there? No. No. This multimeter oh, it's on hold. Why are you on hold? There we go. That was weird. Nothing. Why? What? Let's see if any of these work. Okay, I know which one this... So we've hooked up another wire, a different type of wire, just because it was easier to make the length work out properly, because we had a lot of it. And that's this wire, and it's not doing anything. If I just short these manually, that just does nothing. Why is that? There we go, okay. Whoa. It says this has a... Oh. Have we hooked these up wrong? You likely have. This is soldered as per the pictures, except given that the parts are often different than the pictures. Yeah. Oh. No, they're backwards. That's okay. I'll just flip this. So at the moment, we've got neither normally open or normally closed. We've actually got normally nothing. And then when you click it, it's also nothing. No, that's wrong. It's always open. Not normally open or normally closed. For people who are in the audience who have no idea what I'm talking about, switches are defined by, one way to define a switch is by talking about whether they're normally open or normally closed. That means whether they're connecting the terminals by default or whether they are open circuit. Okay, and then one more, which I can't remember what it was. It's on the back. Just grab that there, put it to the bottom terminal. This should make it normally open. I'm not 100% sure it's meant to be. But ordinarily, if this was using Mac 3, is it Mac 3 or EMC, which are EMC's a Linux CNC thing, that's what it's also called, then it wouldn't matter if the switch was normally open, normally closed. You pretty much just say what type of switch it is, and it self-configures. I'm going to assume it's like that. If it's not, we can just move one terminal, it's no big deal. Anyway, so now we can do the short testing again. That's why it's useful to do this. Okay. Oh dear. Oh, it's... there we go. So this is for the x-axis. Are you? The x-axis. I think you're the x-axis, right? Which mode is this? Is there a motor on the back? Yes. So this goes with this one. This is this, which is the x-axis. Good. I lost it. Are you the x-axis? Yes. That's a yes. So apparently I should wire this in order of X, Y, Z. what he built now. I'm still building the CNC machine. This is the X-Carve CNC, sent to us from X-Carve, and we've only recently decided to build it. This goes like this, and this. Alright, so this, I'm assuming it goes in this one here. These crimps. Ah, that's how these. So this one's not latching into the crimp because I need to crush the cord more. This one was in? Yes. Hey, that was a good noise. That's the noise you want. So these cables, they're actually these are the ones that the X-Carve came with. They're actually too large for these crimp terminals. The insulation stops it from coming in. I'm sure it would have been okay if I had a crimp tool, but when I was using the pliers, I didn't crush them enough. Even though I kind of thought I did, but well, it's not a big deal, I guess. Okay. I crush you, cable. Where did it go? I've forgotten where that came from. It's in the second one, okay. That one. There you go. So now we have. Got to double check the connections again because I have changed things. So I've got it like this. Awesome. Needs more couch feet. Yeah, it probably does. These cables seem a bit dodgy. They totally are. And we've got like 6 or 7 things shorted. What's happening? X, Y, Z, so I need to now identify which one's the Y axis. So shorting the multimeter to the ground, which is common throughout the circuit. Then all I need to do is grab a terminal. This is going to be the Z, there it is, and this is going to be the Y, and it is. Okay, so the next one is this, which is the Y, which is not fitting in the crimp, but I may have over-persuaded it to crush. I think it has been over-persuaded slightly. There we go. Yep, that's what happened. What the hell? Come on, crimp terminal. No, don't lock yet. No. This crimp terminal's weird. It's gotta uncrimp it. Get out. There you go. Further crush the end of this. For those who are just joining us, this is the X-Carve CNC. We've been building it for about 9 hours. Probably another 2 hours, maybe less. Probably less. There we go. There we go. So now we've got X and Y, and now the final axis is of course Z, Z for my Australians, fellow Australians. Okay, this one looks like it's gonna, yep, that worked perfectly. Alright, so now we've got X, Y, Z, and then now it's plugged in to the 2.54mm terminal block. Alright. Yep, so we've plugged it in as per the diagram, and now now it wants me to do something that looks like it's not possible without undoing the machine. It wants me to insert something. Oh no. Oh dear, it wants me to... What? Why? Why? Why would it make me do that? Really, this is unfortunate design. That's what this is. Yeah. Seems like it wants me to put one of these in this rail, but you can't do that without undoing the damn rail. So it's got this picture. It's like, yeah, just do this, but I have to. What the hell? Maybe these can be inserted in a way that I don't have to do that. Maybe that's why these are called insertion nuts. Let's give them a go. So it wants me to maybe put this in like this. No, that's wrong. Can't believe that it would make me do that again. Maybe I'd do that, and then oh, yeah, alright. Yeah, that's a pretty cool thing. Oh, that's alright. I take back what I said. That's a pretty cool thing. Alright, so I now need a M5 16mm screw. I've got two 16mm screws. I'm assuming there's another one for another axis, probably the Y axis. So it just wants me to screw this in here. So I assume that it looks like it uses this to collide with my upside down limit switch. So I can probably, it's safe to go to about there. Let's just bring it back a bit. There will do. Yes. Okay. And we can flip, we have to flip this over. Okay, so I'm going to flip a few of these limit switches over now. So we did this early on. We weren't sure which way they went, and we knew it wouldn't really matter at the end. Alright, so we've flipped this up, and now we're just putting this in here. Now the axes will collide with the limit switch and trigger a limit like this. Okay, so I'm going to have to do this for this one as well, and perhaps this one. I'm unsure if that's correct or not. After this, we're going to have to tighten all of the axes V-groove bearings so that the axes are very secure. Otherwise it's going to be a bit shaky. It's going to be extremely loud. Oh no, this is more of a hassle than I thought it was. There's some bolts in there. How unfortunate. Bolt. You shall be removed. Okay, so we'll just undo these bolts here. And put it in the correct way. So this uses only 3 limit switches. I think I mentioned this in the previous video, but I don't remember. That is tightened. My gosh, how did we do that? Where's my screwdriver? Okay. Yep, so this only uses 3 limit switches. That means that the way it is located is via a zeroing. So every time you turn this machine on, it's going to have to zero, which means it's going to move all the way to the end of one axis until the limit switch is triggered. So just flipping this over now. Here's the precarious part. Finding where that damn washer went. Somewhere. Here's one. It's okay. Just put it back in there. Okay, got the washer on. I've got to get the nut. Put this nut on there. Alright, there we go. So we've now flipped the most annoying limit switch, and we just have to put the other bolt in. There's a washer here somewhere. It's probably fallen into these holes. Where's the washer? Okay, this washer's going to have to be left out. It's fallen somewhere, we'll find it and have to put it in afterwards. Because this is on plastic though, it will maintain a constant force on the bolt. It will act to stop the bolt undoing, kind of like that washer. These are spring washers. People can't see that, but it's a little spring washer in there which has just fallen into that hole and it hasn't come out. Anyway, so now if the video can hear that, hits that switch, which is great. Okay. Okay, I'm going to read the comments. EEV blog, is the time-lapse video still going? I don't know. Perhaps. if it isn't, I don't really know how to... Yeah, it's still going. Dave is the wizard with cameras. I have no idea how to use it. If it stopped going, I don't know, probably take another 10 minutes to figure out how to get it going. Yeah, pepcake, exactly. Where's that other one? So there were two self-inserting thingies. Now there's only one, which is somewhere else, evidently. Ah, here it is. So it's going to probably want me to put this in another axis. Whoa, what? Plug in the electric assembly. Whoa, but I haven't got this in. No. This isn't... Why would you tell me to plug it in? This isn't ready to be plugged in. You're wrong, machine. I know where this goes. Somewhere. Are your ceiling lights connected to the internet? Give him a sing. What? Sorry, I don't know what that means. Alright, so this thing just has to go here. There's no other place it can possibly go. Apart from just about everywhere. Get in. Alright, surely this is wrong because assumptions don't really work. There was one bolt, I knew I have it. I've seen it many times. I've almost got to the end of the build and because I haven't been throwing away the bags anymore, I've covered the whole table in empty bags and tools, so I wonder what all these extra crimps are for. I don't know. So, are you under here? No. Alright, where are you? M5 bolt, show yourself. I have these, I guess they'll work. Yep, this one will work. So Dave and I we were missing a bolt to begin with, a whole bunch of them. So we've been using bolts from other sections to complete the sections we're up to. So, so for some sections we needed to. Whoop! Come on. This is annoying. I have to detach the belt because I can probably do it slowly. So I can't move this quickly because it will generate back EMF. Actually, it'll just generate. Basically, it'll generate a voltage at the driver because the motors are spinning and it may bust the driver. So I have to move it pretty slowly to minimize the back EMF from the motors. Okay, so This was a really fiddly bit before. I had to use an Allen key like this to put the belt into the thing. It's kind of another bit of a hacky, a bit hacky, I think. Yeah. Okay. It actually wants me to plug it in. I don't want to plug it in. I don't feel it says I'm done. Why does it say I'm done? I'm not done. You're wrong, instructions. I haven't even tightened the belts. Okay, everyone's noticed that I've finished the instructions, and it's wrong. It's simply wrong because I need to tighten the belts. Because, like, it'll be a disaster if they're loose. It doesn't square up the axes. That's kind of strange. Ordinarily with CNC machines, one of the things you take the absolute most care with is to making sure all the axes are very square, right? Like when I built my machine, I specifically bought high precision engineer squares, like specifically for that. Does this machine cost $200? I think it costs about $1,000. I could be wrong. I don't know. We got sent it. The X-Carve people, Inventables, they sent them to a few video bloggers. We were one of them. Yeah, they sent them to a lot of video bloggers actually. Okay, so this belt, I'm just gonna pull this as tight as I can before I start doing the actual tightening. Ah, come on, get through a notch or two, or 7. Okay, so now the belt's going to be tightenable just from that side because I've tightened this as much as I can. So originally these were meant to be Allen bolts, but we lost the bolt pack that these ones came in, or we simply didn't have one to begin with. More likely the lost one because it's been sitting next to a pick and place machine that's probably in that box actually. But yeah, we've replaced them with these flathead Phillips combo screws, which are very difficult to tighten past a certain point. Okay, let's get as many notches through as we can. Time to cut this belt. Provided that all the other axes have enough belt. Yep. Alright, so let's cut it. There. Whoop. There we go. Okay. So, now I'm going to do the other side. So notice now I can hardly move the thing. That's because previously these things were loose, so the belt didn't mesh with the pulley. Whoa! There is paper all over the floor. Oh, that's not paper. That's anti-static bag. Okay, so I have to do this 6 times, so there are 3 axes and each axis has 2 of these tensioning bolts. Yeah, so 6 times this machine after I finish this axis. Because this axis has 2, so I'm actually in total have to do 8 of these. 1, 2, 3, 8. Oh wait, no, that's That's wrong, because the Z-axis has a lead screw, which means it doesn't have a belt tensioner. Hooray! Whoa, that's really bad. The belt is not meshing with the belt tensioning device, so it's, oh dear. That's frustrating. How do I re-tension this? Come on. Yeah. Yeah. Once this is tensioned, the belt will push into its own teeth, and that will cause greater meshing, but at this moment it isn't tensioned enough to do that. So, yep, okay. Okay, so I'm just going to have to go back to the other side and pull the belt through again, because the belt is not meshing like it should. My long nose pliers, there they are. Okay, there we go. So I think I'll just tighten this belt like this. Seems to work, and it kind of avoids the belt slipping. So now I can do just a few more turns on this side, if I can. Problem is, when you put the screwdriver in, it interferes. You get collision with the axes, so you can't really get a screwdriver in there. Might be able to at an angle though. Nope, that is insufficient. I know. Pliers are not sufficient. Yes, they are. Okay. Is that tightening or loosening? I don't know. Ah, that's tightening. Okay. So this axis is more or less tightened. We'll just have to pull this through. So these belts are now quite tight. It's still not. I wish these had like a tension gauge. That would be fantastic, because then you'd know exactly how much to tighten each axis. Especially with one with a dual motor configuration, because now you have a different. If you have a different tension on each side of the machine, then you actually have a different number of belts, different number of teeth on each side of the machine. So you might get one tooth difference in the full length of the machine, which means the squareness at one end of the machine will be different to the other. Am I tightening this? I don't know. Now I am. I was loosening it. On account of being backwards from where I was before. Okay, so now we're ready to tighten this Allen bolt here. And I'll just push this through as much as I can. Problem is, each time I don't believe these are going to stay meshed. I think this thing is going to loosen over time. If I can do that by shaking, the machine can certainly do it. Because it's going to shake like crazy as well, yeah. Okay, back to the pliers. Better tighten this axis again. That is a screwdriver. Whoop. Hard to grip on this thing. Round bolt. Okay, I need to move this axis. Whoa, look at those emoticons. That is a lot of emoticons. Okay, so I'm just tightening this for the last bit, and then that's fine. Probably, I don't know. This tightening mechanism, it looked good at first. It's not as good as it appeared. Nah. Oh well, this time will be faster because I kind of figured out a fast way to do this if I don't drop things. Oh, laptop. Okay. 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 So let's just tension that belt like this, and oh, bring this in like there. Whoop. Just got to, whoa. I hate this belt tensioning system. I used to like it. I've changed my mind now that I'm 9 hours older and wiser. Okay. Okay, here's the screwdriver which I was losing. Oh my gosh, the belt tensioner. It slipped. Of course it did, because it sucks. It's not a good belt tensioner. It should be... It could be far better. That is not the screwdriver. Okay, there we go. So that's more or less tight. I just need to... There's a supporting bolt which I must tighten, and then I have to do one more axis. Okay. Nope. Alright, there we go. That axis is done. One more axis. Hooray! Provided that we can find some bolts, which I probably can. Dave brought some over before. Fantastic. Another part that we're kind of missing parts for. So we don't have... ideally we would need a thread locker or Loctite or something, because these don't have a nylon. These aren't nylon thingos. They don't have those nylon stopper things. Okay. Whoa! The thread thing just came completely undone. What a terrible system. Oh, I do not like this belt tensioner. It is not good. Nylox, thank you. Oh, thank you. That would have bothered me. Actually, I would have just gone to like bolt.com and figured it out. Yeah. What's the Allen key for that? Here it is. Okay, so now just got to put this back. That was actually really annoying because this belt, unlike the other one, came completely undone. It's really bad. Not impressed, Inventables. You could definitely do better. Yeah, you're right. I am determined to plug this in. Yep. I do not leave things unfinished. Whenever I can help it. And I can help it. Okay. So just put this in here. I might use one of these other M5 nuts as a lock nut instead of using a using what they recommended, Nylock, which is a weird name. I guess it's a nylon locking nut, which is actually a pretty good name, I guess. Bolt.com.au. That is what I think that's right. I'm gonna test. Bolt.com.au. Yep, it's bolts and industrial supplies. Yep. Haha, we're really getting somewhere now. This is going to be awesome. I'm using a second nut as a lock nut. This is a common way to do things when you don't have a nylock or thread locker. I assume everyone probably knows that. I don't know. I don't know what you know. That would be weird. Ah, this is easier. This is not going to be. This is not going to be good to test. This machine's going to be like really problematic. I can feel it. No, wrong one. That's the right one. My phone. Oh dear. My phone's telling me to leave. Windows Phone must have added this new feature. They automatically tell you when the traffic is good. One moment. I don't want to plug it in. I'm pretty close. I've got all the belts tensioned now. See ya. Have a good night. That was Dave. Alright, so we're just about to plug this thing in. We've got to put this through all these because there was absolutely no step that told you to actually connect this Well, there was, kind of. It's the step that told me to connect this to the terminal header, but it didn't tell me to do anything with the wire, so I haven't. So I was going to bring this through the damn cable carrier assembly. Doop, 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 doop. All right. Okay, so this is certainly going to blow up when I plug it in. I have no real reason why it would do that, but maybe it will. For dramaticness. Yep. Cable carriers. Why are you so annoying? Yeah. Where's that tape wire I had? Whoop. Don't turn it on, take it apart, yeah. Wouldn't that be just like heartbreaking? All this work and it's like, take it apart. Oh man, that would be heartbreaking. The thing is, I'm worried, this thing probably, like, as far as I can see, this thing's not going to be, like, very good performing. It's not going to perform very well. It's going to be alright, it's going to be a router, it's going to be an alright router. But I can't see it being a... I can't see it outperforming what I've already got. Alright, there we go. Now I can just pull this through. Okay, now I'm going to put it through the last cable carrier assembly. And then I'm going to solder it to the motor wire. And then we plug it in. After I tighten these V-groove wheels, which I just remembered I had to do. Even though the instructions have said I've finished, which is crazy. Because after the assembly, everything's loose. Yeah. Okay, where are my pliers? There they are. Yep. Yep. Okay, so here's the spindle wire here. We'll just solder this, I guess. Pull that off. And we'll... I guess I should cut this. Yeah. Yeah. Mm-hmm. Maybe a bit shorter. The worst thing ever that could happen is this cable getting in front of the spindle head. That would be a real disaster. So these things cannot be too long because these carry a lot of power. That looks pretty good. Yeah, I don't know what ampage this motor is, but it's going to be like, at times it's going to be pretty high, especially when it's ramping up on speed. So before you've got substantial back EMF. Yeah. 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 Okay. And then just twist those together. Yeah, electrical tape it. Okay. Just twist those together. Doing a bit of a handshake with the wires. Come on, soldering iron. Warm up. Someone's stream froze when I cut the wire. That would have seemed quite odd. Now I'm going to plug this into like a breaker board, if I can find one. I don't know if Dave has one. We'll find out when I look for one. An inline breaker. They're awesome. I can always put it into a multi-board. Those have breakers. Kinda. Alright, so now just electrical tape it. This will be a real disaster if this no, it's cool. This would be a real disaster if these shorted. This would, yeah, that is shorting the whole supply. It's probably a 20 amp supply. Each motor, NEMA 23s, might draw 4 amps to 6 amps. Probably much lower at times, but absolute max, perhaps. How many motors are there? 1, 2, 3. Is there another? There has to be another. 4. Yeah, so you expect like 16 amps and then maybe even more with the motor, so 5 amps for the spindle maybe. Electrical tape and heat, dun dun, exactly. Yeah, but there's a lot of it. So anyway, this is not a point of high resistance. There's not going to be substantial heat on this joint. Yeah. All right. Okay. So that's pretty neat. We'll now proceed to tighten things. Wunderbar. Okay. This one's really silly. One of the more awkward parts I've done. These are now tight. That means you've got the Z-axes now able to move, which is good because you kind of want it to be able to move. Otherwise it's pretty hopeless. I'm surprised they didn't put anything on the bottom of this, because at the moment you could drive this into the floor. You could drive this whole axis to fall off. To me it seems like there really must be something at the bottom. Alright, so okay, these are all tight now, so that's good. Now I've already done the Z-axis for these, but I do need to tighten the X-axis funny giblet bolt things. Okay, and this is another really awkward piece because they actually wanted you to tighten this earlier on, but I think, if I remember right, but I'm kind of glad I didn't, because during the construction I was flipping the thing upside down and being quite rough with the machine, and it probably would have ultimately loosened, so I would have to do it again. Let's say there, that sounds about right. And I need to use the Allen key, tighten that last bit. Crazy angle. We'll need some Loctite for this, I think, eventually. Oh, that's sounding much less rattly now. It's sounding almost like a CNC router. So if people shouldn't be able to hear that. That's good because it's not rattling. That's how it should be. These ones still are ridiculously loose. What the hell? That is not the correct amount of space. Oh my gosh. So to loosen that, to loosen this as well. That's so annoying. Why would that not be correct? What are you doing? That makes little to no sense because the top ones fit. I loosen this. Does that fix it? It seems kind of okay. I don't know. This is a pretty poor tolerance, these parts, so I don't really know if I've done something weird or the part just doesn't. The part's just not machined very well. I suspect that this might be machining this time. These ones are tight, yeah. Go digit. Okay, that doesn't shake. Oh, it's very solid now. Okay, so that'll be okay for now. If anyone can see little lights going on the control board, that's because in H-bridges you have a reverse diode on the end FETs. So when you if you spin a step motor on that driver, it acts like a full bridge rectifier, and there's a diode on the input of the like decoupling the motor drivers ordinarily, right? And what that means is that you end up powering the circuit through the motor. So often the good thing to do would be to put a series diode to the power for the motor drivers. You can't really do anything about the full bridge rectifier that it forms, but you can do stuff about the other part. So these parts don't appear tight yet. That's kind of alright. Okay, just tightening that. There we go. So that's tightened. This one's completely loose. Why? I know why, because I didn't tighten it. There we go, that's better. And then we need to rotate this. I don't know what these non-concentric nuts are called. They have a, they're going to be something like a jib or gib, but they're not like wedge things. So I don't really know all these except non-concentric nuts. They're nuts. Okay. What? What? How did these come loose? These weren't left loose. How irritating. How are we going to reach these? along those pliers will not reach. As I lift it, then this power board will fall with it. I'll bring it to the edge of the table, put the electronics on the actual CNC. Come on. Real head. Okay. Where's those pliers? What's this? I want to use. Okay. Ooh. So this is the lower nut for the cable carrier chain. Somehow the nuts got loose, even though these are nylock nuts. So I'm just going to let this dangle for a second. Hopefully the terminal block undid. I hate terminal blocks. Damn terminal blocks. Grr. I know, I'll jam something. This. Okay, there you go, it's nice and tight again. I now have to deal with the damn terminal block. Those terminal blocks are terminal blocks, and they suck. Okay. Pretty much half of them have undone, and that's wonderful. Okay. No, don't undo. Cooperate, terminal block. Okay, yeah, okay. Okay. Two of four wires have been corrected from the terminal block, which sucks, again, because it's a terminal block. Terminal blocks just globally suck. Yeah. Some people like them. I guess it's because you can connect any kind of wire to them, really, like stranded, single core, multi-core, and you don't have like the need to buy headers. You just know that anyone with a screwdriver is going to be able to use them. But like they've already made the assumption that we can use crimping tools, so like yeah, it's probably to do with the current requirements. Terminal blocks are pretty good with those. Alright, so this is now loose somehow, and I'll just, problem not resolved because that is a bolt. Oh well. Have to tighten that because there's mains wiring near it. Can't really have loose, yeah, you can't really have loose bolts near mains. That's crazy. Got to be tightened. Absolutely must be. Where are you, Allen key? Okay, so here we go. That is an Allen key. What I need. So this is just, I'm just putting the fan on now so I can take the lower section off without dealing with those parts flailing about. Yeah, that's probably the best way to do it, to tighten those bolts. trying to figure out another way so I don't have to open the thing. I probably should put a screwdriver into it to tighten it. Yeah, the bolt is wedged against the wall, so yeah, that'll be okay. Now I can tighten it. Oh, that was lucky. Ah. Oh, the screwdriver's kind of stuck. Okay. Okay, so that's very tight now. Wires are not completely retarded. Okay, we want to turn the spindle off to begin with. Make sure these terminal blocks aren't shorted. I'm going to shake this, make sure there's no loose things. Just flip it, flip it, flip it. Okay, there's nothing loose. That's great. There could have been a bolt that fell in the power supply. That would have been kind of a disaster. The power supply has to be on 230. Yeah, so it's on 230. Yeah, yeah, yeah. Yes. And we need another breaker board. This is okay, so we've got a breaker board. I'm going to use this as a thing, as an attempt to stop it turning off. So we've got an IEC cable here. Let's turn this off to begin with. Assume I just turn it off. Just plug that in. This is grounded, so it's okay. And then, woo! It's on, and there's no fire. There's not a fire in the room. How fantastic is that? All the bolts are tight. Probably. Alright, time to plug it in. USB. Are these motors locked up? No. No, they're not in their lock position. Yeah, oh no, I'm missing the wireless grounding strap. You're so right. What was I? Oh, that could have been bad, guys. Could have yet, yeah, yet, yeah, exactly. But if it was like drawing way too much power, we would have like. I'm gonna turn this off. Yeah. So if we were drawing too much power, then it probably would have tripped the breaker. So, yeah, no, that's a really good sign. We did just screw some wires into a terminal block, but I don't know. Small victories, mate. Installing driver software. Alright guys, I'm going to end the stream. The build seems successful. I have to sign up for some damn Inventables account to do this thing. So this is an open source design. This is the X-Carve CNC router. It might call itself a mill, I don't know. Install Windows 10 now. Oh, nah. Alright guys, thanks for viewing the stream. Ending the stream on 416 views, that's not so bad. Yeah, good night.